Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 9. Convert sorted list to a binary tree. Given the head of a singly lethal list where elements are sorted in ascending order, convert it to a height balanced binary tree. So what do we mean by height balanced binary tree? Is a binary tree in which the depth of two subtrees of every node never differ by more than 1. Okay. So before solving this, just try to solve this one or two. Convert sorted array into a binary tree. This is a similar question. And if you just solve this question, then just resume with this question. You might familiar with this question also. Okay. Let us begin. Now, so this is my input. This is my input singly linked list. Then my output should be like either like this or like this. So both are valid binary tree as well as both are height balanced binary tree. Okay, first of all, what is mean by binary tree? Okay, in binary tree, is a tree in something like in every node. In every node, the left subtree should be less than that of a root's value, that node's value, and also right subtree. All nodes in the right subtree's value should be greater than the root's value. So this is the property of a binary tree. Okay. And also what is meant by height balanced tree? So height balanced tree is something like the height of both the depth of both left subtree and the maximum depth in the right subtree will be differ in only what? 0 or 1. Okay, the difference will be what? 0 or 1. Take for example, if it is like 0, 1, 2. Now, whether this is a height balanced tree, yes, I can say yes. Okay, what is the height of the, depth of the left subtree? It is 1. What is the depth of the right subtree? It is 1. So, what is the difference? It is only 0, right? It is 0. And here also, this is 0, here also 0. Okay, let me take another example, like now, tell me whether it is a valid height balanced tree. No, right? Because what is the left subtree depth for this 2? It is 1. And for right, it is 0. Okay, for this, the difference is only 1. But for the 0, the left subtree depth is 2 and right subtree depth is what? 0. So I can say the difference is what? 2. So 2 is greater than 1. So I can say it is not a height balance tree. Yes, can I understand this? So see here, this both will be what? A height balance and also a binary tree. See here, for this 0, for this node 0, all the left subtree are what? Less than 0. All the right subtree are what? Greater than 0. For this 10, again, all left subtree is less than 10, minus 10. And also all right subtree is greater than minus 10. For this 5 also. And similarly for this 3 also. Can I understand this? And the height is also balanced in both these cases. So I can say this both can be my output. Anyone who can pretend any node. Okay, now how to do this? Okay, the simple step here is to do like, let us think about it. Just tell me if you want to take the root, right? First of all, we want what? A root here. Okay. This what? A sorter linked list. Okay. Tell me from which, if I take that node as our root, that is which apply our condition. Okay, which should satisfy our condition. So which node I can take? I can take this center node. Why we are taking the center node? You may ask the question. Okay, if I have something like 1, 2, 3, then what is the center node? It is 2, right? It is 2, and we have only one left subtree and one right subtree. Both the left subtree and right subtree are what? Height balance, right? Height balance. But depth is only what? Maximum possibility is 1. Here also maximum possibility 1. Height difference will be what? 0. And if it is like 1, 2, 3, 4, then if I take the mid, you can take mid as this or this. I will take this as our mid, okay? This is our mid. If I take this as our mid, what is our left subtree height? It will be, depth will be 2 maximum. Here it will be 1. So I can say at the max it will be less than or equal to 1. We satisfy our height balance tree. And also see here, if I take this 2, all the left subtree will be what? All the left side will be what? Less than 2, because it is sorted, right? All the right side will be what? Greater than 2, because it is sorted. So I can say it also satisfies the VST condition. That's why we are just taking the middle value. Okay, now how to find a middle value in a singly linked list? Okay, I will demonstrate for this linked list. For rest, you can do. Okay, now initially I will take a slow and fast pointer here. Okay, now let us take this above as a fast pointer, below as a slow pointer. My core logic is that I will move my fast pointer 2 times. Okay, move fast pointer 2 times. 1, 2. Again, move slow pointer only 1 time. Again, move fast pointer 2 times. Move slow pointer only 1 time. Again, whether we have any more? No, because we don't have the next step. We don't have the next step. So we cannot move 2 steps. Stop here. Stop here. What's our mid? We got a mid as what? 0. Can you understand this? We got a mid as 0. Okay. If you want this detailed explanation, just watch my another video in the link list. I will give the link in the description. Okay. Now, we found the mid, right? We found the mid. Now, what is our next step? Just construct the 3 node for this mid. Okay. And just remove this link and take all left side of this link list of our left subtree. So this left subtree consists of what? -10 and -3. Can you understand this? Okay. Now, just delete this link and take this as our right subtree. Okay. And took this right subtree. Now, do this step for entire left and right subtree until it becomes what? A null. Okay. Let me demonstrate it. Here also, slow and fast. So, fast will move 2 times and goes to a null. Slow will be moving 1 time and it will be what? -3. So, I can say -3 going to the next node, going to be the next node. And what is the left of this -3? It is -10, right? So, ignore this link and just send this as -10. That's it. And here is what? A null. So, put a null here. That's it. Okay, now here, what's the mid? Mid is 10, -10 itself. So, -10 and put what? A null here, a null here. Can you understand this? Okay, now again, for this right subtree, initially fast is here and slow is here. Fast will be 1, 2, go to the null, and slow will be 1 time. So it will be standing at 9, right? 9. So cut this link and put this 9 here. Okay, now send the left side of this 9 to what? This left subtree, and send this null to the right subtree. And put this 5 here, then null here, then null here. Can you understand this? Simple. We consider the minus S3 fully right. And also it is what? Right balanced minus S3. That's the important thing. This what? Right balance. Right? So this is like what? This is like the second variety I think so. This is like a second variety. But here it is like 9, 5, yes. It is like a second variety. So we got any one of them. Right? Okay. So what is the time complexity? I can say my time complexity will be O of n since I'm just traversing each and every node, and also my space complexity will be O of just height of this minus S3. Right? This tree is a resultant tree. So we don't count this as a space. But while constructing this, we need what? A rectangle stack. That rectangle stack will be taking what? The size of height. Can you understand this? Now let us see the code so that it will be more clear. Here, this is the code. First of all, if not get it, then just return. If not get it dot next, then what should I do? If not get it dot next means what? It means there is no more elements beyond it. So we take that element alone. So that's a leaf node. Just construct a tree node for that and in dot one. Simple. Now, pre is equal to slow is equal to fast is equal to get. So I'm taking the slow pointer and fast pointer. But you may ask, why this pre pointer? I will tell you. This will be keeping track on the previous node to cut the link. I will tell you. Now, while fast and fast dot next, what should I do? Pre is equal to slow and fast is equal to fast dot next, not next, and slow is equal to slow dot next. Okay. Now, pre dot next is equal to null, which means what? Which means if, take for example, 1, 2, 3, 4. If this is my linked list. Now, I am just traversing here. This is my fast, this is my slow. 1, 2. Here 1. Okay, now, what is my pre? Pre will be here only. Pre will be at this one, right? Now, again, going to the two step. 1, 2. It will be null. And here it will be 1. And now my pre will be where? My pre will be at this 2, right? I want to cut this link. That's why I'm using this pre pointer. This pre pointer's next will be turned to a null. So I cut this loop. Cut this link. And I also cut this link and take this value and take this value. I will tell you how we are going to that. See here. Now, pre of next is equal to null. Root is equal to the node of flow dot value. So I am taking that flow dot value as our root value, right? Because that's the midpoint. Now, root dot left is equal to self dot sorted list to BST. Just a recursion call to the left subtree, and I am taking the head. Taking the head because we got the link right. Now, root dot right is equal to self dot sorted list to BST of flow dot next. I just sent what? I just sent, instead of sending this, I just sent this. So this link will be ignored automatically, right? So from this, I will take this a right subtree. Can you understand this? That's why I'm just sending what? Flow dot next. Okay, then I'm returning the root. Why? Because each and every time we return the root, it will be like it goes to the some recursion calls root dot left and some recursion calls root dot right. Like that. Let me submit it. Yes, it is submitted successfully. Thank you.
Pirai.com.